Need some context, man.
Okay, so final piece. We are talking about harmonic motion. This is sometimes called like spring motion. It's essentially using trig functions to model situations that actually occur. We are going to do a very simplified form, so we're only going to do sines and cosines. But different ways to think about it. If you take a spring, okay, there's a weight attached to a spring, you pull it down and you let go. What happens?
Shoots up.
It goes up. Does it just stop there?
No.
No, it keeps following that pattern. Okay, so that can be modeled with a trig function. Or if you think about like a dolphin's path through the water, it's going up and down. Those kinds of things can be modeled with a trig function. We are going to just be focusing on what's called simple harmonic motion, so just the very basic part of it. So when we are talking about it, we are talking about the position of a point oscillating around an equilibrium position, so it's going above and below some central point, which is what sine and cosine both do. And so it can be modeled with either a sine or a cosine function. It's all the same as what we have been doing, but for whatever reason, when they switch to harmonic motion, instead of putting like a b and an x, they put an omega and t for time. The amplitude is still your coefficient, so your amplitude is a. Period, normal period for sine and cosine is 2 pi, divided by the number in front of x, but in this case we're doing t for time, so it'll be 2 pi omega over omega. And then the only difference, the frequency. Period is how long it takes to repeat. The frequency is basically how many times it repeats per unit of time, and it's just the reciprocal of the period. So now we're just going to jump in with examples. So, suppose we have an object that's attached to a spring. It's pulled down 5 inches from its equilibrium and then released. The time for one oscillation is 4 seconds. So I took my spring, I pulled it down, and I let go.
Does that make the amplitude 5?
So, we want an equation that would model my position. So notation, usually position, they call it s at time t. So first we have to decide, is this a sine or a cosine function? Sine starts at its center. If I pulled this down and was holding it and then I let go, did it start at its center?
It's cosine.
So it's a cosine graph. Now cosine starts at its high point. If I pulled it down, it would be a negative. So we know it's a negative cosine. All right, now our amplitude. How far down did we pull it?
5.
So our amplitude is 5. So it's a negative 5 cosine. All right, we're almost done. So now, what does the 4 represent?
T.
Well, it's the time for one oscillation,
period.
so one period. So period is found by doing 2 pi divided by the coefficient of t, which in this case we usually call it omega. So 2 pi over omega equals 4.
Should be a half pi over 2.
Wait, what does omega represent again?
It's just like the coefficient of t.
Yeah, we were
T
calling
is
it
x.
b before. It's just a number in front of our variable.
So, okay.
So our omega pi over 2. So it's negative 5 cosine of pi over 2t. We're using t instead of x because we're talking about time. Okay, so it's the exact same thing that we were doing, except they're switching up the variables on us. They're using t and omega instead of b and x, but same idea. So if I ask you to determine the position at 1.5 seconds, what are you going to do?
Plug it in for T.
Alright. Let's go ahead and just use our calculators to do this. Make sure you should be in what mode?
Degree.
Radian.
Radian?
Radian, pi over 2. We are,
Oh, pi radian, that is correct.
alright. So radian mode, negative 5 cosine.
What a number.
So this is my height, so it would be inches. I get a positive, so that means it's currently on its way up. Or it's been going up. So it's above the equilibrium point right now. Would a negative position be reasonable?
Yeah, if it were falling back down.
Yeah, if we're pulling it down, it can go below.
To get the omega degrees, cross multiply.
Yeah, I set it up 2 pi over omega equal the period. So I just multiplied my omega over, but it's essentially cross multiplying if you treat it as 4 over 1. Alright, frequency. So frequency is just what?
Reciprocal of period.
The reciprocal of period.
Over pi.
No, what was my period?
Pi over T. Oh,
The period was 4 seconds, so the frequency is 1/4. So that's measured in oscillations per second. So it's saying if the period is 4 seconds, it takes 4 seconds to complete an entire cycle. What this is saying is it does 1/4 of its cycle every second. Okay, so they're pretty similar. Period is just how long to get the whole thing, and then frequency is like in 1 second, how much have you done?
wait, so we found that by using the frequency formula? Or?
You can, I just went back because I told you it was the reciprocal of the period. But you could have done the
No,
frequency.
reciprocal of 4.
Formula?
1/4.
Your omega was pi over 2. And we said the formula we wrote down was omega over 2 pi. So if you did pi over 2 divided by 2 pi, you would get the same thing. Because you could flip and multiply.
And we said that it was 4 seconds, like it takes whatever for 4 seconds to
Mhm.
happen. So then we say period is for 4 seconds.
Mm-hmm. Okay. Let's look at another. Suppose an object is oscillating according to this formula. 8 sine of 3t, where t is in seconds and s of t is in feet. Describe its movement. Okay, so this is kind of vague. Things that we could describe. What is our amplitude?
8 feet.
Okay. So what this means is it oscillates 8 feet above and below the center. Can you tell me what the period is? Normal period 2 pi divided by the coefficient of t, so 2 pi over 3. So that means it takes 2 pi over 3 seconds to complete one cycle.
2.3 seconds sounds so weird.
If you prefer, let's see. You could say approximately 2.1 seconds if you like that better. 2 times pi divided by 3 is about 2.1. Okay, the other thing we do with these is frequency. How do we get frequency?
Zip code period says 3
Mm-hmm. So it completes 3 over 2 pi, or if you don't like that, 3 divided by parentheses 2 pi is about 0.48 cycles per second. So has a little less than half a cycle every second. Any questions on that one? A weight on a spring has an initial position, so at time 0 it's at 2 inches, and a period of 0.5 seconds. So, can you tell me, is this a sine or a cosine?
It's cosine.
Why?
Because it does not start at 0.
Sine has to start at 0. Since this didn't, it is a cosine function. Okay, it started at a positive, so did I flip my cosine?
Nope.
What is my amplitude? 2, because my beginning height was at 2. So it's a 2 cosine. Shouldn't say y, I should say s of t. That's the notation here. It doesn't really matter.
We get my points off if we put 1.
No. Okay. Now I know my period. So I have to find what goes with my t. How do we find that?
Reverse engineer.
Period is 2 pi over omega, and the period of this is 0.5. So if you multiply over your omega,
4
divided by 0.5, so 2 divided by 0.5 is 4. So our function is 2 cosine of 4 pi t. Okay. Evaluate s of 1. So if I put in 1 second, what do we get?
2.
Is the weight moving up, down, or neither at this point? So
It hasn't moved at all.
think about this. At time 0, we started at 2, right? And we know what a cosine graph looks like. It comes down, comes back up. And we know this thing is just going to keep repeating, right? That's the whole idea here. It just keeps going on and on. So, what was my period? So, I got, this was at time equals 0, and I get back up there at 0.5 seconds. So when's the next time we're back up here?
1.
So it's neither.
It's neither.
So it would be neither.
At 1 second, we are back to our starting point. It's been coming up and it's getting ready to go back down, but it's not currently doing either one.
Are we just assuming this is a frictionless plane?
Yes.
Oh, okay.
Because that's dampened harmonic motion, which is, we're doing simple.
We're not doing that one. Okay.
Yeah, there would be some complex calculation.
Yes. There is a method, but we're not ready.
Will we be ready?
We don't want to,
Not in
Okay.
this course, no.
not in physics.
When does it hit its maximum height?
Or not in calculus.
0, 1 second.
Every
0.5.
0.5 seconds.
Shut up, man.
All right, I want you guys to try one.
doesn't
How
really.
am I supposed to take notes for this?
What? Just write the problem down. What do you mean?
I can't follow this.
It's the
Like-
same
No, like
thing.
I'm following here, but.
The calculations. Would you like for me to post a PDF of this notes file on Classroom after I'm done? I would happily do that for you.
I would love if you would do that.
I can do that.
Thanks.
Alright, take a second and look at this and see if you can figure it out. Careful, it's slightly different. Okay.
I got this stuff. Wait, sorry.
Sorry. Okay.
Your period is 15
So it tells you S of 0 equals 0.21. So at time 0, the height is 0.21.
You were right.
So would that be a sine or a cosine?
Cosine.
Cosine. Okay, what is my amplitude?
0.21.
Is it flipped or anything?
No.
Okay, then I gave you the frequency. Okay, how do we get period?
It's the reciprocal.
So period is two things. It's a reciprocal of frequency. So what is 1 over 27.5? If you don't like it written that way, that is 2 over 55?
55 over 2.
Oh, I didn't.
The reciprocal. Oh,
Well,
no,
the
I'm
frequency
wrong.
was
I'm
55
wrong.
over 2.
I'm wrong.
Period is 2 pi divided by omega, and that had to equal 2 over 55. So, cross multiply, divide by 2, so it's 55 pi. So it's 0.21 cosine of 55 pi t.
It's too easy. That's how I did it. Or no, I did it different.
Okay. There are different ways of getting there.
I mean, we did it. the
Solve a
same way.
couple different
We just
thought
changed it
processes.
to a
You could
pretty-
use the frequency formula and just solve for omega. That works.
She made it a pretty fraction.
Okay, I am only giving you 5 problems. Number 6, it says you have to use your graphing calculator and look at a graph. You do not have to do that.